So what that tells me is for that dining room, I've got 8 feet here. I don't have 14 feet here because I got the door, which is 6, 7 feet wide, but I've got about 7 feet and 8 feet. I do have enough space. So what I would have to do is run my pipe over and loop up into the walls as well and back and around. And if I did that on the 2 outer walls and added that extra space, that would give me enough that I should be able to handle the cooling in that room. And that's the only room that requires it. All the rest I can get away with just in the floor. But I went and gave you a house in Watertown, New York, and that one room really does need a little bit more because that dining room is just exposed to nature and the elements in the wintertime. So it will, we can keep our 9-inch spacing and get away with it. And I just wanted to show you that because that's the only room that's really tricky on this project. All the rest of them, you're going to find that the 9-inch spacing works fine. You're going to have no trouble getting the rooms taken care of. The bathrooms you can drop down to 6 inches. That is standard procedure. Do so. But for the rest of the house, you can keep it at 9-inch. And it's just that you're going to have to run it through the walls in the dining room as well. So when I ask you how many feet of pipe you need for the dining room, it's going to be a bit more than what you would calculate from the 117, right? Because you need 164 square feet of space. And again, I'm assuming 30 BTU per hour per square foot based on these calculations. So I'm at the high end of what's listed, but you can do that today with good insulation underneath the subfloor and with the metal plates and the low temperature drops. It will work. You can get those kind of numbers out of a subfloor system. So to calculate the amount of PEX pipe for each room, it's again pretty straightforward. We take the floor space and the wall space if needed. We multiply by our factor. So we needed 164 square feet, right? We set a space. So let's just do that calculation real quick. I went and I killed my calculator. That was a very silly thing of me to do. Oh well. Sorry about that. I didn't mean to kill the calculator right away. Accidentally hit the X button on it, but that's all right. I got the one here on my phone. You'll just have to trust that 164 times 1.34 for that dining room works out to be 220 feet. And I can have a 300-foot loop, so 220 feet fits. And that would be the answer that goes into the box, 220 in the handout for the hydronic heating. And I ask how many feet of pipe do you need, and the answer for this room would be about 220 feet. So with that, you now have the ability to calculate the square footage throughout the entire space. And of course, if you divide the amount of the floor by the maximum loop length, determine number of loops, and the manifold ports for the floor. Now, I'm not asking for that information, but that's how you would get that information if you needed it. Now, this begs a question that what do we do if, like in this case, we calculated 220 feet of pipe, and we can have up to 300. Could I use 80 feet of that to start running into the next room? The answer is yes if they're in the same zone. However, you really don't have 80 feet of extra pipe. Let me show you that. It depends where you places your... Oh, good heavens, I shouldn't have done that. It went backwards. Sorry about that. What I did here is I hand sketched an example of a loop, assuming my manifold's way over here. And what can happen is in a couple of the rooms, it depends where you think your manifolds want to be. If you think the furnace should be here, you may want to use this wall in the basement as your manifold system. You're going to see that you have some loops that are far away from the manifold system, and that could be an issue here that you get these longer length runs. Now, what they will do in a lot of homes is if you have the space in the basement, it's not a finished basement, you're not on slab, what you can do is you can put manifold systems in multiple locations and then run down with a few bits of copper down to the furnace at the end. So you may not have lengths quite this long, but if you think you do, then you would have your 220 feet of pipe here plus 30 plus 30, another 60 feet running, assuming that my manifold's in this corner. So next thing you know, you're close to the 300-foot loop. And I just want you to make you aware that in real life, that's what's going to happen. But again, we don't have the software that does all that for you. I'm not going to ask you to do it by hand because nobody in their right mind would do it by hand anymore out in the field. So I'm not going to ask you to do something that you wouldn't be doing out there working. But just be aware of that when I ask you for the footage per room, I'm not accounting necessarily for these line length runs. So the numbers that you come up with on this project are probably going to be a little short of what they need to be in reality. And I just want you to be aware of that. So don't think when you go out there and start doing these calculations for real, you're going to start using the software. You're going to get numbers a lot longer than what you get for this project, because I'm not asking you to deal with this nonsense. Because right now the only way you can do it is to do it by hand, which means you've got to figure out in advance where to put all these manifolds and then calculate that extra bit of line length. But I won't ask you to do that. The hot water heating turns out to be fairly straightforward. There's two very simple options in the system. I just want to make sure you are aware of those because you're always going to get asked. The combination boiler is the simplest, where you have a boiler within the boiler. So you've got the heating element, and it just heats an internal tank that's also going to be used for your hot water system for your sinks and your baths. And it's a tank just within the boiler, and it contains the hot water. It's nearly instantaneous recovery time. That's the beauty of that system, is that it's very hard to run it cold. The other option is an indirect boiler with a separate side tank. So what you're doing is you're boiling the water in the one tank, and then you're transferring it over to the secondary tank, which is a little more like a hot water heater system in a house that's air cooled or heated, right? I've got a hot air furnace, and I don't even have my hot water heater as a gas fired affair, and it's a totally separate unit. I've got it. It has nothing to do with my HVAC. But with these, when you have a boiler system, if you're doing hydronics, it's kind of crazy not to have your hot water included. So these two systems are pretty well done with it. The indirect boiler is not quite as fast a recovery as the combination boiler, but it's still a matter of minutes. It's not too bad. Whereas my gas-fired affair, if I pump it dry, as it were, and there's nothing but cold water in the tank, it takes a good 20-25 minutes to get the heat back up if somebody goes and takes an incredibly long shower. Both systems are treated as an extra zone attached to the boiler. They're always considered a second zone because, of course, the temperature requirements are different. Water, generally, you don't want water much above 120 degrees coming out of your shower or your sink, or you're going to scald skin. So you've got to keep it down to 120. So it has its own temperature regulation. So it is treated as its own separate zone, just so you know. And obviously, both of these systems, the one thing you have when you're letting your boiler heat your hot water is you're running your boiler all year. So even in the summer, you're doing some minimal cycle running to make sure that the hot water is there. Obviously, a lot less running than you do in the winter. So the cycles are much farther apart. But it may only need to run a couple, 3 times a day, depending upon how much water you use and how long people take showers and and if they all take them at once or spread out through the day or whatever. Whoops, I'm sorry. That went a little faster than I anticipated. So I said for a 4-person home, usually If you round the boiler size up to the next available size, when you're sizing the boiler, that roundup will take care of the hot water as well. And you don't really need to do much math other than just make sure that it's there. Normally, a 40 to 50 gallon tank is all you need for 4 people. Some people like to do 60 because they want they want to have the capacity if they really want to soak themselves in the tub a long time.